good morning to one and all present here. Hope all of you are having a wonderful day and hope all of you are keeping well in these testing times. I am Yukta Lodha, student of MSc Mathematics at SMIT. I will be your MC for the day. To get things started, I will be calling upon my good friend Anisha Chetri to deliver the welcome address.
Thank you, Yukta. Good morning, one and all. I am Anisha Chetri, and it gives me immense warmth and great pleasure to welcome you all to this webinar on real analysis and problem solving of real numbers and sequencing series on behalf of Sikkim Manipal Institute of Technology. Firstly, I'd like to welcome our respected director, Sir, Dr. Ashish Sharma. I would also like to express my heartfelt gratitude to Sir for granting us the permission to organize this webinar. I would like to extend my warm welcome to our guest speaker for today, Sir Riyas, Assistant Professor of Mathematics, Khadir Mohideen College. Thank you, sir, for joining us despite your hectic schedule. I would also like to welcome our respected HED Sir of Mathematics Department, Dr. Anjan Raj Chaudhary. Thank you, sir, for giving us the opportunity to organize and conduct this webinar. Further, I'd like to extend my warm welcome to all the faculty members of the Mathematics Department who helped us, who worked tirelessly and helped us throughout to organize this webinar. And last but not the least, I'd like to welcome all the participants. We are thrilled to have you here, to have you participate in our webinar. I hope that today inspires ideas and discussions and will help us have a deep understanding of the subject and a better approach to our problem-solving ideas on real analysis. I would now request my friend Yukta to take over and continue further with this program. Thank you.
Thank you, Anisha. Now I would like to request Dr. Ranjan Roy Chaudhary, Head of the Department of Mathematics, SMIT, to give us overview of the webinar. So over to you.
Good morning to one and all. Good morning to all the participants and good morning, special morning to my department colleagues. But this is another initiative from our department just to make mathematics more appealing to the students, especially in this part of our country's Sikkim, because of its geographical locations. The students, especially BSc first year levels, they do not have the good access to the special courses such as real analysis and all this related areas. So we felt that one should have some kind of series of lectures that will stimulate the students and create their problem solving attitude, and with this, by attending this series of lectures. And this is a special initiative from our department. I congratulate Dr. David taking up this initiative. And these things obviously doesn't work with the active support my department and colleagues who all played a key role in having this done. And of course, the special this thing to congratulate to all other my departmental research scholars for taking part and actively supporting us in getting it this thing organized. I would like to extend my this support to all my colleagues and also request Professor Riyas to who have kindly consented to take part in this webinar series. The Department of Mathematics has a rich tradition in delivering all this kind of this series of lectures. For the last 4 and 5 years, we conducted 2 seminars and workshops, linear algebra in 2017 and 2020 workshop. We organized a workshop on game theory and spatial matrices. Both are funded by National Board of Biomathematics. So this department has a tradition in in organizing something. And also this gives we take regular initiative in providing support to other departments. The department has 12 faculty members, and along with there are 10 research scholars who are actively supporting in terms of their knowledge base and in terms of their research work. So we have a rich tradition in all these areas. Okay, so now over to David for this.
Thank you, sir. Now I'm glad to introduce you to the speaker for the day, Mr. S. Riyazuddin, Assistant Professor at Khadir Mohideen College, who is well known for explaining the real analysis in an intuitive manner. First, he goes through the geometry of the problem before getting into the proof in his unique way. He completed his BSc Mathematics from Khadir Mohideen College and his MSc Mathematics from Bharati Dasan University. He has 3 years of experience as an assistant professor of mathematics. He has been a guest lecturer at numerous workshops. He has won numerous prizes in quizzes, puzzles, solving, and paper presentation, including first prize in state level competition, NECOMAT 2018, Integration 2018, Math Zest 2018, Gematics 2017. Sir, it is our honor to have you here. I take this opportunity to invite you to take up the session. Over to you, sir.
Hi, this is Riyas. I begin in the name of the most merciful Almighty. I wish peace be upon you. First of all, I would like to thank the event organizer, also my senior, Dr. David George Michael, HOD of the department, and the director of this institute for giving me this opportunity to share my thoughts with you. Also, I'd like to thank each and every professors, seniors, and friends who taught me. And I also like to mention my parents here for their support throughout my life. Without further delay, we proceed to our webinar. First question is, what is the function? Can anyone tell what is the function is? Can anyone define what is the map from the set X to Y?
A function is a relation from a non-empty set to another non-empty set.
Okay. Not all relations are function, but there is a special condition in that. There is some condition in that.
For every A in one set,
function is a special relation in which every element of first set has only one image.
In particularly, function is a rule which defines every element in X to a unique element in Y. Okay. What do you mean by graph of F?
In graph of F, we plot the points like where X goes to Y from function to F of X.
Okay.
X in horizontal and F of X in vertical.
Okay, that's not what I'm asking. Actually, graph of F is a set. It is a collection. Collection of what?
Set of points.
Set of points?
image of a function.
If it is in the 2 dimension, then it is in the form of x comma f of x. This is the set of 2 tuples.
Yeah. That is that's what I'm asking. This is the collection of x comma f of x ordered by x comma f of x. Sorry, such that x where is in x. I just defined the f from the function is from x to y. Okay, this is a graph of f, right? Okay, when you define when we draw the graph of f, this is some function, just maybe. Okay, let this be a function. What can you say when every line parallel to x-axis intersects at least one time, at least once in the graph of f? I'm asking, what you will say when every line parallel to x-axis intersects at least one point in the graph?
So graph is surjective.
Yeah.
Function is surjective, sir.
Function is surjective. Okay, right. So if it comes, then f is surjective. Just we mentioned the on2. Okay. What do you say when the line parallel to x-axis cuts 2 points in the graph? When it cuts 2 points, what do you say it?
The function is not 1.
Not 1. Yeah, it is not injective. If cuts one time only, then exactly saying that if f cuts, sorry, the line parallel to x-axis intersects at most 1 point, then it should be a 1, right? Okay. Just tell me what is the Archimedean properties?
For every real number, there is a natural number which is greater than that real number. Sir.
So if we have x, y greater than 0.
Let x greater than 0 and y be a real number, okay.
Then we have a natural number in n, k in n.
Okay. Okay. I just mentioned it as an n. No problem with it. Okay.
Such that nx is greater than y.
Okay. Nx is always greater than y. It shows that for every x positive, there exists a natural number n such that nx greater than y, right? First is also some version of Archimedean property. For every real number, there is a natural number such that n greater than y. That is also a version of Archimedean property. Actually, Archimedean property is nothing but natural number, set of natural number is not bounded above, right? Okay, this question was asked in December 2016. Let f belongs to open interval 0, 1, then which of the following are true? Is are true? What you can say about the first option? For every n in n, there exists n such that s greater than or equal to m by n. Is it right or not?
Yes, sir.
How? By Archimedean property?
Yes, sir. M is also a real number.
Yeah. Can tell the proof of it. Just not regular proof, just hint.
Sir, one problem, your voice is something breaking.
I think it is not breaking right here.
I think
is it audible for everyone?
It's perfect actually in my end. Maybe subtitle might have some internet issue, I guess.
Yeah.
Yes, sir. Now it is clear.
Okay. Anyone say if it is true? Anyone say the proof of this?
Sir, s belongs to 0, 1. That means s is greater than 0, and m is m belongs to natural number. That means it belongs to R.
Okay.
And so there exists a natural number such that Sn is greater than m.
By Archimedean property, there exists a natural number ns greater than m. This implies s greater than m by n. Okay. Therefore, first option is right. What about the second option? What you say about for every m in n? For every m in n, can you give a natural number such that s less than m by n?
Sir, I think it is just the negation of the first one. So by the first one is holds the Archimedean property.
Sir, it might hold and might not.
Okay.
Sir, if n is not, sir, excuse me, sir, it will hold.
How?
Sir, s is between 0 to 1, and since we can take any n in capital N, so we can assume n to be 1.
Yeah, that's right. If n equal to 1, then m by n equal to m. What then?
Sir, since s belongs to 0, 1, then n is a natural number. M will be greater than
1. That is less than or equal to m. Okay. Therefore, this option is also holds. What do you say about this option? For every m in n, there exists n in n such that s equal to m by n. What do you say about m by n?
Sir, this is
No
not
m by n exists. Not true, sir.
Why?
So because no m or n can exist as that as lies between 0 and 1.
No, for every m in n, there should be some. There may be some n, such that m by n belongs to 0, 1. Example, let m equal to 1 and n equal to 2, 1 by 2, which belongs to that set.
Sir, it will not be true if s is a irrational number.
Yeah, that's a key. If s is an irrational number, but in the right hand side, m by n is a rational number. We know that a irrational number is nothing but a real number difference a rational number, right? We mention a irrational number as a or difference q only, right? Therefore, this may be whole. Okay, what about the last option? Here the key was m plus n. Here the key was m plus n.
Sir, it is false.
Why?
Sir, because minimum of both m and n is 1 and 1, and that will become 2. So s can never be.
M plus n always greater than or equal to 2. This implies s is always greater than, if it is true, then s is greater than or equal to 2. But it is contradiction to s belongs to 1, right?
But I think argument for 3 is also useful for can be used for 4, because both m and n can be considered as rational numbers, so their sum is a rational number.
Can you tell your point clearly?
If m and n are from natural numbers, they are rational numbers also.
Yeah.
So their sum is rational.
Yeah.
So same argument for 3 we have used, we can use for 4.
Yeah, we can use it also.
Okay. Taking any rational number between them also will.
What?
Taking any rational number, n also might work.
Yeah. If s equal to any rational number, this may not be true because of this.
Yes.
Because sum of the natural number has to be natural, cannot be rational number purely.
Yeah. Okay. What do you say about the upper bound? When you say alpha is upper bound of some a, when you say alpha should be an upper bound of a.
So every element in A is less than equal to alpha.
Yeah. For every element in A should be less than or equal to alpha, right? What do you say about least upper bound?
Minimum of the upper bound of A.
Huh?
Minimum of the upper bound of A.
Okay, minimum of upper bound is A. How you define it?
Every upper bound
Let beta
of
be
set
any
A.
upper bound of A.
There is two options to define it. Any number which is greater than alpha is an upper bound. So any upper bound is greater than or equal to alpha, and also if anything less than alpha is not an upper bound. Is it clear?
Yes, sir.
Okay. 1 minute. I'm checking where is that question was. Okay, the following question was asked in December 2017. Just consider this. Let R be the set of real numbers and Q be the set of all rational numbers. For 0 less than or equal to epsilon less than or equal to 1 by 2, let A epsilon be the open interval 0, 1 minus epsilon. Which of the following are true? Just leave it there. Leave it first. What do you say about alpha A epsilon? What is the set A epsilon? A epsilon is the set. It is given 0, 1 minus epsilon. The question was about supremum of A epsilon and infimum of A epsilon, right? So just find the infimum and the supremum of A epsilon. What is the infimum of A epsilon? Infimum is nothing but greatest lower bound, right? What you can say about infimum of A epsilon? Let epsilon be any at 0 less than or equal to epsilon less than or equal to 1 by 2. What you say about infimum of A epsilon and supremum of A epsilon?
Infimum is 0.
Infimum is
0. And supremum is half.
No, supremum is
Supremum will be 1 minus epsilon.
Yeah. Suppose you can't say epsilon is, you can't say supremum is 1 by 2. Suppose epsilon equal to 1 by 4, what will happen? So suppose epsilon equal to 0, then the set will be 0, 1. 1 by 2 belongs to this set, and 3 by 4, like that, there are some elements in this set. Okay, there is nothing. It is very clear now. Supremum of A epsilon equal to 1 minus epsilon, right? Okay. What is the first option here? Just check supremum of 0 less than or equal to 1 by 2, less than or equal to 1 by 2. What you can say about it? You are counting this 1 minus epsilon and taking supremum of this. You said that supremum of A epsilon is 1 minus epsilon. What you can say about this this set? Supremum of 0 less than or equal to epsilon less than or equal to 1 by 2.
It should be equal to 1.
Just to first define what, just say what is it equal to. Supremum of 0 less than or equal to epsilon less than or equal to 1 by 2. It is nothing but 1 minus epsilon, right?
So what is supremum 0 here?
Yeah.
Supremum 0?
No.
No, what is that?
I'm just clearing that supremum of 0 less than or equal to epsilon less than or equal to 1 by 2. Supremum of A epsilon, that set should be equal to supremum of 0 less than or equal to epsilon less than 1 by 2, 1 minus epsilon.
Oh,
Because
okay,
you are
sir.
saying,
Got it. Got it.
yeah, we proved that supremum of epsilon is 1 minus epsilon. Just we are substituting this. Okay, now say what is the supremum of this set? Just to say the supremum of the set 1 minus epsilon such that 0 less than or equal to epsilon less than or equal to, okay, 1 minute. Just to say supremum of the set 1 minus epsilon such that 0 less than or equal to epsilon less than or equal to 1 by 2. Just to say what is the supremum of this set.
So one, no, sorry, half.
So it should be 1.
Why?
1, sir.
For epsilon equal to 0, this there is a element here that is equal to 1. Okay. For epsilon equal to 0, there is an element equal to 1. There is no element greater than 1 appear here. Okay, that is 1 is clearly it is 1 is a upper bound. For any number less than 1, there is a element here. Just for you can choose the element here, right? It is very clear now. The supremum is equal to 1, but the option is strictly less than 1. So this option cannot be true. Everything clear in that? Is everything clear in that?
Yes, sir.
Yes, sir.
Okay. What you say about if epsilon 1 is less than or equal to less than epsilon 2, and compare infimum of A epsilon 1 and infimum of A epsilon 2. Regardless of epsilon, what is the infimum of A epsilon?
0.
0. So therefore, for any epsilon, infimum of A epsilon is 0. If it is true, if the second option is true, then what will you get? 0 less than 0, right? So this is absurd. So we will, this option is not possible. Right? What do you say about 0 less than epsilon 1 less than epsilon 2 1 by 2 implies supremum of A epsilon 1 greater than supremum of A epsilon 2. First to say what is supremum of A epsilon 1? What is supremum of A epsilon 1?
1 minus epsilon 1.
1 minus epsilon 1. What is the supremum of A epsilon 2?
1 minus epsilon 2.
What you say about if epsilon 1 is less than epsilon 2, what you can conclude about 1 minus epsilon 1 and 1 minus epsilon 2?
So 1 minus epsilon 1 is greater than 1 minus epsilon.
Yeah, just do it by step by step. Epsilon 1 less than epsilon 2 implies minus epsilon 1 greater than minus epsilon 2. This implies 1 minus epsilon 1 greater than 1 minus epsilon 2, right? Therefore, supremum of A epsilon 1 is greater than supremum of A epsilon 2. Therefore, this option is true, right? What do you say about this option? Okay, before going in it, I forgot to ask you something. What do you mean by dense set?
Sir, if we choose any element from the set, any two elements.
Okay, I just mentioned D subset of X. When you say D is a dense set in X.
So when we choose any two elements from D, X and Y belong to
X. Oh.
Then there exists Z.
There is a okay. Such that
X comma X less than D less than Y.
Yes, X less than D less than Y.
Y.
Yeah. For any two number, there is a element from the dense set which is between those numbers. Okay. Between those open interval X comma Y. Okay. Now consider this. What is the supremum of A epsilon intersection Q? What you can say about this set Q?
Sir, it will collect only rational numbers between 0 to 1 minus epsilon.
Okay, that's not a problem. I just asking what you know about Q in the as a subset of R.
Q is dense in R.
Yeah,
Q is dense in R.
Q is dense in R, right? Now say, what you can conclude that supremum of A epsilon intersection Q. What you can say about supremum of A epsilon intersection Q?
So it will be 1 minus epsilon only.
Yeah. Why? Suppose you can choose if there is a Y less than 1 minus epsilon. By Q dense, there should be an element between Y and 1 minus epsilon, right?
Yes, sir.
Let we choose that some Q1, right? Less than Q1, less than 1 minus epsilon. This implies Q1 is clearly belong to A epsilon. Is it right or not? Q1 belongs to A epsilon. Is it right or not?
Yes, sir.
No.
Why?
There may be some case that Q1 does not belong to the set. You can get a element Q1 such that belongs to A epsilon intersection Q. That is not a problem. I just said that this Q1 belongs to Q only. There is some case such that Q1 does not belong to the set.
Yes, sir.
Let's choose Y equal to minus 1. Minus 1 by 2 is a rational number between the minus 1 and 1 minus epsilon, right? This Q1 may be that minus 1 by 2. Suppose Y is negative, just to choose a rational number between 0 and 1 minus epsilon. That's it. If Y is positive, there is nothing to prove, just Q1 belongs to that set. If Y is negative, just to choose a rational number between 0 and 1 minus epsilon. Okay, this is enough. This implies supremum of this set is equal to 1 minus epsilon. What do you say about this set? What do you say about the set R difference Q?
Sir, it is also a dense set, so it will also be 1 minus epsilon.
1 minus epsilon. Therefore, this both supremums is equal to 1 minus epsilon. Therefore, this option is also true. Right? Okay. Just move on to another question. What is the definition for the function f is 1, 1? Can you define it?
No two element in the domain corresponds to the same element.
simple terms.
If x1 is not equal to x2.
Okay, that's a definition. Just asking you in simple terms.
Sir, if Y belongs to the image of F, then it will have a unique pre-image.
No, I'm just asking that different elements in X has different images in Y.
Every element is mapped uniquely to the elements.
You are saying, I'm not saying you are wrong. Just think like this: different elements in X have different images in Y. That is equivalent to say that x not equal to y implies f of x not equal to f of y. Okay, when you say f is on 2,
so if the range Z is equal to Y.
That's not a problem. If every element in Y have a pre-image. Yeah, that is the question. Okay, I think those two are okay. I forgot to ask something. To prove a condition for every element, what do you have to prove? Just I am asking a simple question. How you prove that a statement is true or false? I am just asking. Every person attending this webinar is listening this problem. Okay, this is my statement. Every person attending this webinar is listening to this problem. To prove this is true, what do you have to check? Okay, just the same you. When you say this statement is false,
if we pick one participant who is not listening, then we are done. That means we have to disprove it.
Yeah, if you want to prove it, you have to say that every person is listening to this problem. If you want to disprove this, you have to check. You have to find the person who is not listening this, right? That's the key. Okay. Next question we are going to see was which was asked in December 2017 CSIR problem. Let Z denote the set of integer and Z greater than or equal to 0 denote the set of set 0, 1, 2, 3, set of non-negative integers. Consider map from Z greater than or equal to 0 cross Z given by 2Z. I just forgot to mention it. 2Z given by f of m comma n equal to 2 power m into 2 power n plus 1. The question was, then the map is surjective but not ejective like this. Just we will prove what is it 1 1 or on 2. Just we will check this function as 1 1 or on 2. If you done it, the answer is always, you can gain the answer. Can anyone say this function is 1 1 or on 2?
So it is not on 2, sir.
Why?
Because 1 has no pre-image.
1 does not have a pre-image.
1 has no pre-image.
Okay. Suppose, yeah, there is a simple More simple question, element there. 0 also does not have a pre-image. Suppose 0 equal to some 2 power m into 2 power n plus 1 implies 2 power m equal to 0 or 2 power n plus 1 equal to 0. These both are not possible. Okay. Yeah, 1 has a pre-image. 1 has a pre-image. If m equal to 0 and n equal to 0, what you can say about 2 power 0 into 2 power 0 plus 1, that is equal to 1, right? 1 has a pre-image.
N can't be 0, no, sir. So n can't be 0.
Why?
Oh, Z.
Yeah, n can be 0. 1 has a pre-image. 0 does not have a pre-image. Okay, therefore this function is not onto. This f is not onto. Okay, what you say about 1 1? What do you say about 1 1? Just try to prove it.
Sir, I think f is 1 on because if we pick up two element m and n and their functional image will be different.
Yeah, you can prove it like there's an easy way to prove it. If f of x equal to f of y, then you can choose like that. It is easy way to prove. This function is 1 1, that is right. Easy way to prove is if f of x equal to f of y, then x equal to y. This is an easy way to prove it. You can check it by your own. If anyone have the doubt in this, we can prove here. If anyone have a doubt in this, okay. This question clearly it is 1 1 and this, therefore what is the option? Injective but not surjective. Is it clear?
Yes,
Shall we
sir.
move on to next question? Okay. What do you say about bounded sequence? First of all, what is a sequence? What is a sequence?
A sequence is a function from n to r.
Okay. If it is a real sequence, it is a function from n to r. Okay, that's enough. What is bounded sequence? What is bounded
If
sequence?
range state is bounded.
What? It's range is bounded, right? Okay, just to be well, just x is a function from n to r. We will define as x of n equal to n, xn. Okay. Then say what is a bounded sequence?
So, modulus of xn for
Okay. There
n
is some m positive such that modulus
is
of
less than
xn less
is
than or
less
equal
than.
to n. Okay. That is that obviously means xn, the collection xn have an upper bound. Okay. Not upper bound. It has modulus of xn that has an upper bound. Okay, what do you say about the convergence sequence?
The convergence sequence is bounded.
Oh, that's not I'm asking. That is true. I'm asking about what do you say about convergence? What is the definition of convergence sequence?
If a sequence has a limit, then it is a convergent sequence.
What do you mean by a limit?
If the limit superior and the limit inferior are equal and they exist finitely.
Okay, those are the theorems. I'm just asking the basic definition of convergent sequence.
Can you say a sequence?
Yeah.
A sequence is convergent when after a few steps we can see the distance between two elements of the sequence is decreasing.
Okay. We can say a sequence xn converges to some x if after some the final stage the elements in the sequence terms of the sequence get closest to x. We can define by definition for any distance given, for any epsilon given, you can get a stage such that for n greater than or equal to n naught, what do you get? Distance between xn and x is less than epsilon. This is what we are saying. We say that xn converges to x if after some stage the terms of the sequence get closest to x. Okay. Do you remember the theorem, Bolzano-Weierstrass theorem? Anyone remember Bolzano-Weierstrass theorem?
Every bounded sequence has a limit point.
No. Okay, that's true, but every bounded sequence has a
limit point.
Is convergent.
Convergent subsequence.
Has a convergent subsequence, yes.
Yeah, Bolzano-Weierstrass theorem was every bounded sequence has a convergent subsequence, right? The following question was related to these things, which was asked in December 2019. Let an be a bounded sequence of real numbers. Then what you can say about this? We will start with last option. There is a subsequence of an which is convergent. This is the Bolzano-Weierstrass theorem, right?
Yes, sir. Last one is true.
Okay. What do you say about, suppose there is some, if you get a subsequence, can you generate one more sequence through it? If you get one subsequence, can you generate one more subsequence through using that subsequence? The question was, if you get one convergent subsequence, can you generate one more convergent subsequence for the original sequence?
Yes, sir.
How?
Not necessary.
Sir,
if the original sequence is convergent, then only.
No, you can generate one more subsequence. Suppose A and K was the convergent subsequence. Just I mention it as A and K. That means AN1, AN2, etc. Right?
Yes, sir. So we can change AN1 into something else, then it will become a different subsequence.
Very
And
easy that we will remove the first time and consider this as a second subsequence. Right?
yes, sir. Yes, sir.
That was also a subsequence. There is nothing wrong with it. Okay. Can you generate one more? Remove
Yes,
two
sir.
times and you can proceed like this. You can proceed like this for infinitely many times. Okay.
You can proceed k minus 1 times.
What?
We can proceed k minus 1 times until the last one lasts.
No, this
No, we can
sequence is,
proceed infinite times like this.
yeah.
Because in ANK means it is a finite limiting term. So
No.
k is a
I'm not saying about finite limiting time. A and K
okay,
is
okay,
just,
fine.
I
Okay,
am saying this as A and K varies in N.
okay.
Okay. This is standard notation for the sequence, right? Okay. If you find a sequence, one subsequence, then you can generate infinitely many subsequents throughout that sequence. Okay. What you say about the first option? Every subsequence of a sequence AN is convergent. If AN is bounded, can you say every subsequence Y? Can you give a counter example?
-1 to the power n.
Yeah, sequence -1 to the power n. The sequence is bounded, but this is not okay. This is not convergent. Can you say every subsequence of the sequence is not convergent? Here say every subsequence of the sequence AN is convergent, right? You have to say one subsequence which is not convergent. You said choose AN equal to, just you are mentioning that choose AN equal to -1 power n, right?
Don't you use the same idea of writing in?
No, every sequence is a subsequence of the same sequence, right?
Yeah.
That plays a role here. This AN is also a subsequence of AN.
So we can find a subsequence such that it does not converge.
No, just a simple thing. Every sequence is its own subsequence.
Yes, sir. Yes, sir. Yes, sir.
Okay, the sequence is subsequence of AN. It is not convergent. Okay, so therefore this option is not true. What do you say about there is exactly one subsequence of AN which is convergent? This says that, right? We can
Not
generate
true.
infinitely many subsequence. Therefore, this is also not true. Okay. Everyone clear with it? Okay. Let's move on to algebra of limits. Suppose xn converges to some x and yn converges to some y. What do you say about xn plus yn?
It converges to x plus y.
X plus y. What do you say about 1 by xn?
It converges to
1 by x converges to 1 by x given x is not 0. Exactly.
1 by xn converges to
1 by
1 by x
is not equal.
provided non-zero terms.
xn and x also x should not be 0. Consider the sequence xn equal to 1 by n. These terms are non-zero, but it converges to 0, right? Suppose if x equal to 0, then you are saying this. You are understanding it is clear, right? Okay. 1 by xn converges to 1 by x, provided xn and x not equal to 0. Okay, just we move on to the problem which was asked in June 2019. Suppose xn be a sequence of positive reals, let yn equal to xn plus xn divided by 1 plus xn. Then which of the following is true? What is the first option? Xn is convergent if yn is convergent. Is it true? Xn is convergent if yn is convergent. Is it true?
Maybe we'll check the second option first.
Yeah, yn is convergent if xn is convergent. I think everyone which someone may confuse with if-then statement, right?
Sir, xn is convergent. That means 1 plus xn is also convergent.
Yeah.
So xn is convergent and 1 plus xn we can. Yes, exactly.
1 plus xn converges to 1 plus x. Okay. Yeah.
Sir, we can consider another sequence yn equal to 1 plus xn. Then xn by yn is also convergent.
Yeah. I just forgot to mention something. Xn into yn is also converges to x into y. I just forgot to mention that in algebra of maths. Okay. This 1 by 1 plus xn converges to 1 plus x implies 1 by 1 plus xn converges to 1 by 1 plus x. Why? Because xn is a sequence of positive reals, right? And this implies 1 plus xn is also a sequence of positive reals, and 1 plus x not equal to 0. Even if x equal to 0, 1 plus x is not equal to 0. This 1 plus x is always greater than or equal to 1. There only then only 1 plus xn converges to 1 by 1 plus x. This implies xn by 1 plus xn converges to converges to x by 1 plus x, right? Okay. Therefore, second option is true. Just to check the first option now. Why do you say xn is convergent if yn is convergent?
So for this problem, for this first option, we can find out xn in terms of yn. Then we can find the solution.
Okay. Okay, that's a big problem. Don't just see it simple in a simple way. Just think of.
So if I can think of a contradiction here, such that y converges but x does not. I guess I can think of one.
Think of?
I guess if I try, I can think of one. I can give it a try.
Just a minute. Just choose yn equal to, just simplify it. Yn equal to, what you get? Xn divided by xn into 1 plus 1 by xn, right? You can just think of 1 by xn. Can you find the sequence now? Such that yn converges but xn does not converges.
Sir, also we can do another way, that is yn equal to xn by xn upon 1 plus xn. Then from there we can track xn equal to yn by 1 minus yn. Say we can yn is convergent, then 1 minus yn is necessary not to be convergent.
What are you saying? Xn equal to xn by 1 plus xn implies xn equal to yn by 1 minus yn.
Yes,
you are
sir.
saying this?
Yes, sir.
How is this possible?
Sir, by simple algorithm, by just doing calculation.
I'm not getting it.
Sir, yn equal to
xn equal to x. Xn equal to n, sir. Example, sir.
Yeah. Xn equal to, okay, I'm just not verifying this.
N.
Just choose xn equal to n. Right, just choose xn equal to n. Then 1 by n converges to 0, 1 plus 1 by n converges to 1, then the sequence yn converges to 1, but the original sequence xn does not converges. Okay, yn convergent but x0 is not convergent, therefore this option is not true. What do you say about the final fourth option? Xn is bounded if yn is bounded. What do you say about y?
Not true.
Why?
Not true.
So, the previous thing, what we saw, xn equal to n, xn wasn't bounded, though y was bounded.
Okay, let's give the answer. But you can find the bound of yn without anything.
So it is always less than 1.
Yeah, because xn is less than or equal to, not less than or equal to, it is less than 1 plus xn. It is always less than 1 plus xn. This implies xn by 1 plus xn is always less than 1, right? Therefore yn is less than 1. Yn is always less than 1. Okay, you can conclude this option is true because even if xn is not bounded, also yn is bounded. But okay, this option is also true. If xn is bounded, we can find the bound using that also. Therefore, this option is also true. But note that yn is always bounded. Not necessary. This is xn bounded is not necessary. Okay. Yn is always bounded, even if xn is not bounded, the sequence yn is bounded.
Sir, how do you know about the lower bound?
Lower bound is always 0, right?
The xn's are real.
Yeah.
Yeah. Okay, sir.
By 0.
That's why I'm just asking about just of xn plus 1 plus xn. I'm not considering this because each xn are positive. This modulus is equal to xn divided by 1 plus xn. That's why I'm just asking about xn plus 1 plus xn. Okay. Can we move on to next question?
Yes, sir.
Okay, same trick, I think. Okay. I think nothing is needed for this question. Just move on to the next question. If xn is a convergent sequence in R and yn is a bounded sequence in R, then we conclude that. This question was asked in December 2018. What will conclude that?
Sir, xn plus yn is bounded.
Just consider, okay, that option is true. Xn plus yn is bounded.
Bounded.
What is the fourth option? What about the fourth option?
So it will be false.
Yeah, because xn plus yn is always bounded. Xn plus yn is bounded. It is a subsequence of xn plus yn. Then this option is not true because this xn plus yn is the bounded subsequence of this xn plus yn. Okay.
And third one is also false.
Why?
By Bolzano-Weierstrass
Bolzano-Weierstrass theorem. Yeah. By Bolzano-Weierstrass theorem, it is true. It is this question. Sorry, this option is false.
Sir,
What do you say about the first option?
So first one is also false. We can find such that it is not convergent. We can find
just to say two equations, two say sequences.
So 1 by n and 1 minus 1.
Yeah.
Or minus 1 to the power n. I mean, 1 by n and minus 1 to the power n.
Just to choose xn equal to 1 and yn equal to minus 1 by n. 1 power n. Okay.
Yes, sir, this is also true.
Yeah. Therefore, this option is also false. Okay. Now move on to next question. What is say when you will say the set was finite? When you will say the set A was finite?
Sorry to interrupt. Yes.
Yes, sir.
Guys, we wanted to make it as very, very interactive. Means expect everyone to interact with, get the benefit out of it. Because the speaker is going at a pace that everyone can pick up. This is why we are going very, very slow. Did not worry about the time limit. We are interested in solving even 10 problems for the complete session. That's okay. But all the 10 problems, every one of you has to interact with this first. We keep this opportunity open for all of you, not only for very few of you. Please make sure that every one of you get involved in the session and get out of the most benefit you can get it out. Thank you, Riyas.
Thank you.
So finite sets means if we can list the elements of the set. In the other words, it can be called a countable number of sets.
For a set is said to
But
be
if we
finite.
can find a mapping from natural number to the set and finite natural number to the set, as in
we just say what is that finite set?
A set which contains a finite number of elements.
Yeah, that's okay, but
technical definition.
So another definition we can call. Yes, if we can map a bijective mapping from the set of natural number to the set, to the given set.
Natural number system.
Repeat it.
That will be numerable, not finite.
Yeah, that is countable.
Yes.
Cardinality of A is finite, sir.
What?
Cardinality of A is finite.
We will define the cardinality later. Later we define the finite set itself. Okay. First we define what is finite set.
Maybe we will define IN first, then later we.
Yeah. Let's define IN first. What is IN? IN is the subset of a natural number. One to n, right?
So if we get a bijective mapping from IN to the set A.
Yeah. A set is said to be finite if there is a bijection from A to IN. Okay. Is it right? This is right, but there is one more word which is just missing. What you can say about A is a empty set? Is it finite or not?
Yes.
Yes, sir.
But you
Yes, sir.
can't give
Finite.
a bijection from the A to IN. A definition of finite set is if A is empty or there is a bijection from A to IN. Okay. We can say the set is finite if either A is empty or there is a bijection to A to IN. Is it clear now? When you will say the set was countable or numerable, right?
So when we get a bijective mapping from natural number to the set, or
Again, is this right?
Empty.
No.
Can
you what do you say about IN? Is this set is countable or not?
Yes.
IN is countable, but you can't give a map to N, bijective map to N, right?
If we can define a map from the set to
a
natural number.
surjective map.
No, definition was a
simple map.
Definition itself contains something. A set A is said to be countable if it is finite or there exists a bijection to N. Okay, if set was finite, then it will be considered as countable. Just read the definition carefully. There is in the definition it should be there. A set A is said to be countable if it is finite or there is a bijection from A to natural number. Set of all natural numbers. Okay. Okay, just we'll move on to next question. Okay. What do you say about this function? These options. This question is from December 2017. Which of the following is necessarily true for a function f from x to y? If
So
f is 1 to 1, first one
is not true.
Why?
So if the image of f is not equal to y, it will not be true.
Just
if
give a counter
image is
example.
not equal to the range.
Just give a counter example for it. This is very easy.
Sir, if we take f from real number to r plus, f is equal to x square if we take.
Okay.
And then g from so y will be the y will be whole r here, and g will be from g will be square root of positive square root of
Okay, don't make it complicated. We can get a simple functions from x equal to 1 comma 2 and y equal to singleton set y. You can choose a function, any function. Just a converse, sorry. Y is a singleton set and x is a singleton set and y is a doubleton set. Define f of 1 equal to 1. This is a 1-1 function, right? This is a 1 function. There is a only one function from y to x. That is a constant function. If you define any function, that should be a constant function for this set. Clearly, g of 2 equal to 1, right? What is f of g of 2? F of 1, sorry, f of 1 that is equal to 1. You can give a function for this f, you can give a function g from y to x such that f of g of y equal to y for all y in y. Okay, it is a simple function you can give. I think this is not that complicated. It is very simple. I'm just thinking of this number only. If you get a second number to same number, that was the idea was. If you get two elements mapping to same number, that you can't get this type of function. That was I am just thinking of. Okay, what you say about, just leave the second example first, second option, just solve third option first. If f is 1 1 and y is countable, what do you say about the x? Can x be finite? If f is 1 1 and y is countable, implies x is finite?
No.
What you can choose? Give a counter example there.
Sir,
You have to find.
will be finite.
So we can choose x to be the set of natural number.
Okay.
And y to be integers. And we define f of n equals to n.
Okay, true.
Okay. The function is?
F
the
of n
function is
equals
1
to
1.
n.
The function is 1 to 1 and y is countable, but x is not finite. Yeah, you can choose that.
You very well choose whatever the x value. Take any countable x and take y also equal to x.
Equal to x.
And consider
I
the
just
mapping f of x equal to x.
I just choose x equal to y equal to any natural number. You can get a, if you give an identity map, that should be 1 1, but x is not finite. Not necessarily natural number, any countable set.
Most of the time we try for a complex examples.
Yeah.
Many times just a very small example.
Don't think so much complicated. It is very easy only. If you see it as easy, you can get a very simple examples. Don't complicate much for this type of questions. To solve CSIR exam, not only the knowledge plays the role, timing will also plays the role there. You have to solve the problem as minimal time you take, like how quick you can how quick you can solve the problem. Try to solve the problem as quick as possible. Okay, what do you say about the fourth option? If f is onto and x is uncountable, then y is countably infinite. If f is onto and x is uncountable, then y is countably infinite. Is this true or false? Just answer by intuition and then prove it.
Sir, it is not true.
Okay, what is the counter example?
So if I take y to y has only one element and all x is, it is surjective. Sorry.
Right. If
Y
x equal
cannot
to,
have only one element.
I can hear. What is it?
Oh, no,
Y is a singleton set.
Yeah. Could be any singleton set.
Yes,
But
sir.
give a
The
constant.
rule is true, I guess. If
Just give a constant function.
yes, sir.
F of x equal to.
F of
Sorry.
x equals to x.
Sorry.
1,
That
2, or
just I
3.
mentioned, I guess 1. Yeah. F of x equal to 1.
Yes.
This function is onto function, but y is not countably infinite. Okay.
Yes, sir.
Now, what do you say about the second option?
It has to be true.
Okay, it has to be true, but what is the reason?
So because if it's surgical,
Subjective.
When the surjective map is defined, it automatically becomes 1. Because g of y is equal to y, you can say.
I'm asking about for given f is onto, can you find the function g from y to x such that f of g of y equal to y? You have to define the function. You have to say the function what g is. What is a f? What is a if f is onto? What is the definition of f is onto?
Every element of y has a preimage in x.
Yeah. Given any element in y has a preimage, right? That means there exists xy such that f of xy equal to y. For any given y, there is an element. Right? Choose this as a element you want. Define g from y to x by g of y equal to this xy.
Yes, sir.
Yeah.
By the existence of G, F is already 1 to 1 also.
Yeah.
So that means F is bijective function.
F is not 1 1. Where is the f?
No,
We are not
we are
mentioning
saying
f is
G
1.
exists, no, sir.
We are not saying that f is 1 1.
No, by the existence of G itself, F becomes 1 1.
No need.
Because if F is not 1 1,
Yeah.
G becomes 1 to many function.
Yeah, we can choose at least one element there. Consider this just a minute. Consider this f equal to f from just I choose x equal to z and y equal to n. Okay, define f of some m equal to modulus of m. Okay, z minus 0. I will choose it because for simplicity. Just or we will add 0 to this. f of m equal to modulus m. This function is onto function. We can define g of some natural number equal to what I mean is g of some natural number equal to that natural number itself. G of n equal to n. This is a function for this f, right?
Yes.
This will look there. This function is not 1 1. This f is not 1 1, but there is a function.
So f has to be 1 1, I think.
No,
because
this f
the
is not 1
function
1.
is onto, so the cardinality of y and x should be same.
Yeah, I'm saying this x equal to z and y equal to, wait, just y equal to n union singleton 0, right? F of m equal to modulus of n. Minus 1 and plus 1 maps to same element. I choose g of n equal to n, g from y to x, such that g of n equal to n. This function is not 1 1, but there is a function like this.
The argument is not for all g f means 1 1. That's the argument. Has to be 1 1 any g.
Yeah.
So I can give a g where f is onto but not 1 1. For example, our Riyas has given. Take set of all integers and map minus 1 and plus 1 to 1 itself. It will become an onto function. So definitely that function is not 1 1. Still you can define this g such that take the element in the natural number system and map it to the same number, identity map. That satisfies the second option, f is not 1. Anyway,
yeah, I can give like this also.
That's not the question. Question was something.
This is not f inverse. This is a identity map. You can generate identity map using this. That's it.
Yeah.
This is not a f inverse.
It's not really an identity map also, because
look like
may not be equal to y all the time.
Yeah.
I'm saying not just identity map all the time, because g of y may not be equal to y all the time.
Yeah. I'm not saying g is an identity map. F composite g is an identity map.
Yes. Composite g is an identity.
Just so you can choose this also for your example. X equal to minus 1 comma 1 and y equal to 1. This function is constant function. From the x to y is a constant function. You can choose g of 1 equal to minus 1 also. But f of g of 1 equal to f of minus 1, which is equal to 1. Is this clear?
Yes, sir.
Shall we move on to next question?
Yes, sir.
Okay. What you can say about this x? Consider the set of sequence x equal to xn such that xn belongs to a doubleton set 0, 1 and y equal to xn in x such that xn equal to 1 for at most finitely many n. This question was asked in December 2016 CSIR net question.
So third option is true.
Yeah, I'm just asking about what is x and y. Is x is countable or not, and y is countable or not. I'm just asking that question only. I'm not going to the option first. Just asking what do you say about this x and what do you say about this y?
Sir, x is countable.
Y?
X is uncountable and y is countable.
So X is a sequence, right? So how can it be uncountable?
Because it belongs to a
It's
state
not a sequence.
0, 1.
Okay.
X is a collection of
A
sequences.
state
It's
of
not
sequence. Okay.
whose terms are 0 or 1. That's only.
X is uncountable, Y is countable.
Yeah, just say how X is uncountable. You can just think of X as a function, right? Sorry, sequence as a function, right? This is a collection of function from n to 0, 1, right? X is a collection of function from n to 0, 1. I think you already proved this as an uncountable. This is an uncountable set. How will you prove it? Suppose this is countable, then there should be a bijection from X to natural number. Then you can enumerate this like this: F1, F2, F3, etc. Right? If you found a bijection function, then you can enumerate like F1, F2, F3, and so on. Define a function G from n to singleton. I think this size 0 to 1 by. This is a very simple simple point. I think there is a proof. G of n equal to 1 if
X is
f1 of n equal to 0. This it is very simple thing to that is like you are choosing a function. There is not a matching this each of a function in there. I think you proved it already. Just work out with this g of n, and you can prove that this g of n is not equal to any f of n, fn. Because suppose if it is equal, then g of n equal to 1 implies fn of that n is not equal to 1. Okay, it is very simple, and y is countable because you can see this as a set of all eventually constant 0 sequence, right? If your sequence has first time only a 1 and other terms as 0, like this will look like a countable union of countable sets. This yn is you can give a proof for it. Yn, this is a regular problems. These two are regular problems. You can give y as a countable union of countable set, like a n cross n, like that. This is a subset of actually this is a subset of eventually constant 0 sequence. Eventually constant 0 sequence is a countable set, and this is also a countable set. Actually, this option is true. You can try it. If you have any doubt, you can ask. You can ask us. This is just a regular.
Can you explain how is y countable? What is y? At least xn is equal to 1 for at most fine. So every sequence it contains one element has to be 1. That is what the statement is saying.
At most finitely many n. That implies the sequence may be like suppose it will has a fifth element as 1, then other elements should be 0, like that. If n equal, I just mentioning like simple cases. there may be a sequence x1 equal to 1 and other should be 0. X5, at most x5 have a 0, sorry, x5 has 1 and others is 0. Can you get this? What I am trying to say is,
remember, we are actually counting the sequences, counting the elements.
Yeah.
So if we leave only finitely many people can have one, then what are the different type of sequences you can generate out of those constraints? That's the question. Reduces to only countably many. It's just found finite union of countable sets, right?
Finite sets, like countable sets, right? Like n cross n, like that.
Yeah.
Not perfectly n. 1 cross 1, like that. Yeah. I'm just saying about C not C00. This set is countable, but this Y is subset of this set only. The proof of C, this will work on this also. Okay. Can we move on to next question? What is well ordering principle? Well ordering principle.
Sir, any subset of natural number has a least element?
Yeah, that's the well ordering principle. Any subset of a natural number has a least element. Okay, that means we can arrange any subset of natural number as an ascending order. That's a how I say. That's a simple way of saying well ordered principle, right? Okay, I think it is enough to say that. I think this is this question is a regular theory question only. That is a characterization of countable sets. That's only this problem. This question was asked in December 2018. Let S be an infinite set. Which of the following statements are true? If there is an injection from S to N, then S is countable. Is it true or not?
Yes, sir.
True.
How? You have to show a function bijection from S to N, right? If F from S to N is 1, 1, can you say there is a bijection from S to N? What do you say about subset of a natural number? Is it countable or not?
Sorry, sir. Subset of natural number.
I'm asking about what you can say about subset of a natural number. Is it countable or not?
Yes, sir. It is countable.
Yeah, subset of any countable set is countable. Now, can you define? Can you find the sequence? Sorry, can you find the bijection from S to N? What do you say about f of S?
Will be a subset of N.
N. Therefore, this f of S is countable.
Countable.
Yeah. Then there should be a bijection from this to this. Shall be mentioned as a G. Okay.
So we'll have.
What do you say about F? How? See, because this f is from s to n, this is 1 1, but this function from s to f of s is bijection.
Yes.
Then we can composite these two.
Yes.
Right? G
Yes, sir.
composite f is the function from s to n, which is bijection. Okay, therefore first option is true. What you can say about second option? If there is a surjection from s to n, then s is countable.
Not true.
If it is not true, just give a. Can you give a countable example for the set? Yes, there is a surjection from s to n, but s is not countable.
Sir, if we take S to be whole R and such that or R plus such that up to 0 to 1 every element goes to 1 and 1 to 2 every element goes to
Okay,
2.
and that's okay.
Like
Can you? That is okay. Can you choose your set as like this? Not necessarily. I'm just going in the way that you have already known a function from this set to n. Greatest integer function. Everyone remember the greatest integer function?
Yes, sir.
Greatest integer function, do the trick here. Because every element from interval 1, 2 goes to 1. Everyone okay with it? I'm choosing s equal to 1, infinity and choose the surjection function as a greatest integer function. Then that function is subjective, but s is uncountable. Therefore, second option is not true. What do you say about the third option? What do you say about the third option?
If we take s as real number,
yeah,
then s is uncountable.
Give an injection function from n to s.
Yes. Identity function.
Yeah, identity function. Identity function from n to s. Not.
N to r.
Okay, f of n equal to n defined. Then is this function is injection function, but s is uncountable. Therefore, this option is also false. What do you say about the fourth option?
Fourth option is true.
How? If it is true, then you have to give a bijective function from n to s or s to n. Given there is a function which is surjective to n to s, can you give a bijection function from s to n using this f? Can you give any function from using this function?
S equals to n.
What?
S equals to n type.
I can get what you are saying.
S equals to n.
S equal to n. I'm asking about what is the function from s to not necessarily n. There is a function, one function from S to a countable set. You can give a since first option is true, you have to give a function, one function from S to n. Can you give any function using this f? I think these are our regular theorems, right? What let any x belongs to S. What you can say about f inverse of x? What do you say about f inverse of x?
It will
after some stage, the terms of the sequence get closer. Okay.
Yes, sir.
For definition, for every epsilon positive, there is a n naught in n such that there is a n naught in n such that for all n greater than or equal to n naught, modulus of xn minus xm is less than epsilon. Okay. This is a definition of Cauchy sequence. What is the relation between Cauchy sequence and the convergence sequence?
Every convergence sequence is a Cauchy sequence.
Also, the converse also true. Sequence and every convergence sequence is Cauchy sequence. Okay. What is say about let x1 equal to a and x2 equal to b? If you define the function xn equal to xn minus 1 plus xn minus 2 divided by 2 for n greater than or equal to 3, what do you say about this function? Is it convergent? Is this function is convergent? Actually, this function is convergent. This function is converges to some x, that x is equal to a plus 2b plus by 3. Okay. Consider this question, that x1 equal to 0 and x2 equal to 1. And for n greater than or equal to 3, define xn equal to xn minus 1 plus xn by 2, xn minus 2 by 2. Then which of the following is are true? By this statement, x1 equal to a and x2 equal to b, let a equal to 0 and b equal to 1. This function is converges to, this sequence is converges to a plus 2b by 3. That means 0 plus 2 into 1 by 3. That is equal to 2 by 3. Right? This sequence converges to 2 by 3. Then what do you say about the option 3? Since this sequence is convergent,
it is Cauchy.
It is Cauchy. Okay. What do you say about the second option?
It is false because the sequence limits to at most one limit.
Limit of the sequence is unique.
Yes, sir.
Okay, therefore this is a false. What do you say about the first option?
It has to be monotone.
It's not monotone sequence. Just consider first 3 times.
So x3 is equal to 1 by 2, so it's not monotone.
Yeah. Therefore, this sequence is not monotone sequence. Okay, what is limit supremum of xn? And what is of limit infimum of xn?
Supremum of the limit of the subsequence of the series of the sequence.
Yeah, just define what is the limit supremum of xn. In words, this is a limit. This is the infimum of the supremum sequence. That means if define yn equal to y capital N equal to supremum of n greater than or equal to n xn, then this lim sup equal to infimum of this yn, right? In words, infimum of n in n, supremum of n greater than or equal to n xn, right? Similarly, limit infimum is equal to supremum of n in n, infimum of n greater than or equal to n xn. What is the relation between lim inf and lim sup? What is the relation between lim inf and lim sup?
Limit infimum is less than equal to limit supremum.
Lim infimum of xn is less than or equal to lim supremum of xn. Okay. When will this will be equal? When is these two terms are equal?
If xn is convergent.
If xn is convergent, then lim infimum xn equal to lim supremum xn equal to what?
Of xn.
Lim of xn.
Limit of xn. If convergent, then these two are equal. If this is equal, then xn should be convergent, and that converges to this point. This is a if and only statement. If lim inf of xn equal to lim sup of xn, then xn is convergent, and that limit is equal to this one. Okay, just consider this question. This question was from December 2019. Let the xn be a sequence of non-negative real numbers, then which of the following are true? What do you say about first question, first option? Is it true or not? Can you give a sequence whose lim inf is 0, but it's not convergent? Not necessarily convergent. Maybe its limit is not equal to 0, but you will say a sequence whose limit inf is 0, but it is not convergent. Can you tell it? Can you say the sequence? Any sequence?
1, 0, 1, 0, 1, 0.
0, 1, 0.
1, 0, 1, 0.
2, 0, 3, and so on. Okay. This sequence, limit infimum of this sequence is 0, but this sequence is not convergent. Hence, Also, xn squared is also not convergent because xn squared is 0, 1, 0, 4, 0, 9 and so on. Okay. If you want some more sequence, let's choose 0, 1, 0, 1, 0, 1 like that. Limit inf of this sequence is 0. Okay, no problem. You can take any sequence. Both are look like same. The sequence is not xn squared is not convergent, but limit of this sequence is 0. What do you say about the second option? Lim sup of xn equal to 0 implies lim xn squared equal to 0.
Sir, again, not true.
It should
Why?
be true.
Not true.
Okay. Whatever it is, just prove it.
Sir, if we take -1, 0, -1, 0.
What is given here?
Oh, okay, sir.
It's true. Because lim sup is this tail of the sequence. So obviously it will be the limit of the xn.
So it is true.
Okay.
It is true then.
Why? Just prove it. This is very simple only. Given that lim sup of xn equal to 0. But what do you know about lim inf? Lim inf of xn less than or equal to lim sup of xn, which is equal to 0. But what do you know about lim xn? Sorry, lim inf of xn. These terms are non-negative real numbers. Therefore,
Greater than 0,
what do you
sir.
say about the infimum of xn?
Yes, greater than
This
0.
is greater than 0. Because of this this inequality, you can get lim inf of xn equal to lim sup of xn equal to 0, which is a limit of the sequence, right? If xn converges to 0, then what do you say about xn squared?
Converges
xn squared
to
also
0.
converges to 0. Therefore, this option is true. What do you say about the third option?
True. Not true.
Not true.
Why?
Sir, 0, 1, 0, 2, 0, 3. Yeah.
This example will work. 0, 1, 0, 2, 0, 3. Lim inf of xn equal to 0, but this sequence is not bounded. What do you say about this fourth option? When you find a sequence whose limit inf is greater than 4, whose squares limit inf is greater than 4, but lim inf is less than 4. Can you give any sequence?
A convenient.
What is the limit superior of the constant sequence?
Yeah.
Yes, sir. Sir, I was saying in the first example you gave, 0, 1, 0, 2, there if I replace 0 with 3, constant 3, then limit infimum of x square.
Okay. There is a very simple sequence than this also. What about the constant sequence 3? Yeah, this will work.
Yes, sir.
Just look out of simple examples. Don't much complicate anything.
The idea is lim infimum and limit superior both are actually same for a convergent sequence.
Yeah.
So you can use that idea and get a constant sequence. Square is greater than 4, but definitely that limit may not be greater than 4.
Greater than 4, that's only.
So what is the easiest convergent sequence? That's my question actually, originally. Easiest convergent sequence in the life is just constant sequence.
You can any sequence plays the trick, but constant sequence, any convergent sequence have lim inf and lim super equal. You can find a sequence whose limit is less than 4, but whose squared is greater than 4. The simple way is the constant sequence xn equal to 3. That's only. So this option is also wrong. Okay, can we wind up here?
Yes, Riyas.
Thank you, everyone.
Thank you,
sir. Email or this phone number.
Okay, sir.
Okay,
Thank you, sir. It was a very informative session and very motivational too. Could see things in a different manner, and hope it helps me. It will definitely help me to solve problems. And now I would like to ask the participants if they have any questions.
Any participants have any questions?
The session is open for questions. You can even ask any questions like what do you have to do for next.
So which book will you suggest? Where should I practice for CSIR net?
I do not suggest any particular book for all subjects. For real analysis, you can choose Dr. S. Simulation and Ajit Kumar sir books. Basic concepts in real analysis, right? Before taking it, you can read the book Foundations in Mathematics, which was written by Kumar sir, Ajit Kumar sir, and Baba something. I don't remember the name. 3 authors. Baba Kumar Sharma. Yes. You can read that book and then go to a book of Riyas by them. That book is very nice. You can read it by own also.
Now I would like to call upon my good friend Rosha to deliver the vote of thanks.
Good afternoon, everyone. We finally came to an end of this long webinar, and I, Roshu Gurung, will be presenting the vote of thanks for this webinar today. First of all, I'd like to thank our guest webinar speaker, Sir Riyas, for visiting and enlightening us with his knowledge. Today's webinar was informative with interesting views. It gave deep insight with the topic at hand. I'm greatly sure that it will help us benefit in our future studies and our entrance as well.
Thank you,
Sir Riyas, for taking out your time from your busy schedule and teaching us about the topics today.
Thank you.
I'd also like to thank our director, Dr. Ashish Sharma, and our HOD of Mathematics Department, Dr. Anjan Ray Chowdhury, for giving us permission to organize this webinar today and inviting Sir Riyas to conduct it. A very deep thanks to all the faculty members of our Mathematics Department. Especially a very warm thanks to Sir David Raj Michael and the team of students who worked really hard to organize this event and make it a success. Also, thank you to all the participants who attended this event today, and hope you all had a great learning experience.
Thank you, Rosha. Thank you, everyone. Next week on 4th of Feb at 3 p.m. we have a webinar on continuity and differentiability. It would be great to have you guys. Let's make the most out of it. So see you next week. With this, I conclude.
Yeah.
Thank you.
Thank you all who have been part of this webinar series. I'd like to personally thank Riyas for taking out his time from my end as well. I would also like to thank, in fact, a lot of thanks to the first year MSc students of Department of Mathematics in SMIT who have really worked hard to put up all this show very well. Thank you guys. I really appreciate your team effort, and I expect the same team effort, in fact, in a more elegant manner in the upcoming webinar as well. Thank you all. We'll see you by 4th of February, 3 p.m. the second talk on this similar series. Thank you all. Thank you, Riyas.